In lesson 5, we're going to talk about some things, so points, segments, and then some things called zigzags. So we're going to figure out when segments are congruent. So first off, let's take a look at this statement. So the statement says if A is a point on a plane, just meaning a flat surface, and B is a point on a plane, then A is congruent to B. Do we think that that's true or false? So try to prove this claim by explaining when you can be certain that a claim is true, or try to disprove it by explaining why it cannot be true. Okay, so either if you think it's true, you're trying to prove it by explaining why you know for certain it's true. Or if you don't think it's true all the time, say why you think it's not true. And something called a counterexample is an example, a specific example of when this doesn't happen. So pause the video, talk through if you think a point on a plane is always congruent to another point on a plane. True or false? So hopefully through your discussion, maybe you came up with that this is a true statement, because if two figures are congruent, it means that there is a rigid motion that will take one figure to the other. So we can definitely do a translation and translate point A to point B on the directed line segment AB. So that's one option, is you could have justified this by saying, yes, translating A to B on directed segment AB. Another way you could have said it, okay, is that you could come up with a reflection. Okay, so it's if you reflect this over the perpendicular bisector of segment AB, so if we reflect A over the perpendicular bisector of segment AB, definitely going to work as well. Okay, you also could have justified this with a rotation. So you could have said, I could do a 180-degree rotation around the midpoint or the middle of these two. Okay, so the middle of segment AB. So again, if we thought of there being a segment here and we found the midpoint of it, so the middle of it, you could do a 180-degree rotation of this segment and A would rotate to B. So that means, in fact, this is true in all cases. So let's take a look at this next one. This is not in your textbook. So let's take a look at this statement. It says, if segment AB is a segment in a plane, and segment CD is in the plane, then segment AB and CD have to be congruent to one another. So if we have a segment AB and we have another segment CD, is AB guaranteed to be congruent to CD? Again, prove this true by justifying it and explaining why it has to be true all the time, or disprove it by saying why it might fail in a case. And you could draw a counterexample to this as well. So pause the video, discuss that, come back. So hopefully you ultimately came up with that this conjecture is false, because all they told you was that you have a segment AB. So here's segment AB. And you could even measure this and say, okay, I'm going to draw segment AB and it is 3 centimeters. Then you could draw segment CD. Okay, and here is segment CD. And you could say segment CD is 5 centimeters. Those two segments are not congruent and they use the information that was given. Only thing that was said was AB is a segment and CD is a segment in a plane. That's it. Are they congruent to each other? Nope, not all the time. Okay? So is there a way that we could change this conjecture to make it true? What would you need to add to this conjecture to make sure that it is true all the time? So in order to make this true, we would have to add something about AB and CD having the same length. So that's what I changed. I changed 3 and 5. So something to do with if segment AB is in a plane and CD is in a plane and they're the same length, then AB is congruent to CD. So that would be a true statement, and that is the one that is in your textbook. Okay, so go ahead and look at that. So if AB is in a plane and CD is in a plane with the same length, okay, so see how they added that? Then AB is congruent to CD. So remember, congruent means that there is some type of rigid motion that will move AB to CD. Okay, so that means that there's some type of rigid motion. So let's prove this. Okay, so let's prove that if these are the same length as each other, then they have to be congruent. So first, let's translate A to C. So now if we move this segment and we move A over to C, okay, so now let me maybe duplicate this. So now we're going to move this segment, we're going to translate A over to C. Okay, so here's A prime and B prime. Next, we would want to rotate segment, we would want to rotate clockwise around point C until B prime coincides with D. So until B lands on D. Now, how do we know that B is going to land on D is the question here. Because we can move this point and just set it on top of C because any point can translate to another point. So I'm just moving A to C. But how can I guarantee, how can you justify that B prime will land on D? Okay, so how do we know that? This is part of proving it. What can you say to convince me? Okay, so point B prime has to land on D. Why? Because the two segments are the same length or distance from C. Okay, are the same length, which guarantees that they're the same, that they're going to land on each other. Okay, so B prime is the same distance from C as D is because A prime and C are on the same spot. Okay, so we've already put A and C together, so we know that this length from A to B is the same length as C to D, and since A is the same point as C, now it has to land there. Therefore, since rigid motions, a translation followed by a rotation, take segment AB to CD, then the segments are considered congruent. All right, so let's practice, okay, using this one. Now, this is, again, not in your book. So we're going to get into some proofs, okay? So we're going to get into proofs on something called zigzags. They're like this, where it's basically just a segment, two segments, okay, that form an angle. So what they've told us is that AB is congruent to XY, and I've drawn two options for the second zigzag. Angle B is congruent to angle Y, and side BC is congruent to side YZ. Okay, so now we don't know which one we're talking about here. So I just drew two options. So segment AB is congruent, segment AB and XY are the same length, okay, because they told us that they're congruent. So these are the same length. So they are congruent. Okay, therefore we know that there is a rigid motion since congruent means there is a rigid motion that will take AB to what? Okay, so rigid motion that will take AB to XY. Now we're going to say, okay, because we're proving this. So now in our brains or in our heads, we're going to say, all right, so we know AB and XY are the same length, so that makes them congruent. That's what we just proved in the last activity. Therefore, we know that there's a rigid motion that will take AB to XY. So I know there's a rigid motion. That's by definition. So now you're going to say, all right, so we're going to apply that rigid motion to figure ABC. So we don't actually need to state the whole rigid motion. We don't need to say, all right, we're going to translate A to X and then we're going to rotate B to Y. We don't need to say that. We're just going to say, since those two segments are congruent, there definitely is a rigid motion. So apply the rigid motion that will make it move there. So now you can just pick this up and go set it on that segment instead of having to go through all of the steps of translate, rotate. Okay, and you can just set it there. Okay, or if it was on this one, you could just set it here. Okay, so you could just set it. All right, we're going to just do the rigid motion. Okay, we're just do the sequence of rigid motions. Okay, that will move it over to that one. Okay, now again, I don't know which one the drawing looks like, and that's going to come into play in a minute. Okay, but what you just did was said, all right, I'm going to move it. I'm going to take that rigid motion that will move it over onto that one. So now that we've gotten AB lined up with XY, okay, these were the two options that could have happened. It could have just landed on it like this, okay, where it just landed exactly and things seem to line up. The other option, okay, is that it landed like this. So there are two options. Okay, and I know this is weird when we're looking at the picture, okay, but there are two different options that this could happen. Either it lands on it and we're fine, or another option is that it could have landed this way, in which case we need to do a reflection. Okay, so if necessary, so when you're proving this, so you would say translate to get AB on XY. Then if necessary, reflect figure AB across what line? So across XY, the one that's matched up, so that point C is definitely on the correct side. Okay, it's on the same side of XY as Z. So we don't want it over here. We don't want it on the wrong side of XY. We want it on the same side as XY. So if it's not on the same side, you're telling your reader to flip it. Okay, well, flip it. Make sure C is on the same side of XY. Okay, if it's not, flip it. If it is, fine. That's why it says if necessary. So do it if you need to, don't if you don't. So now that we have C on the same side, okay, so whatever you've done, if you needed to flip it, maybe you didn't, okay, whatever you needed to do, okay, now C is on the same side. So C prime, okay, which is the flip, so C prime must be on what ray? Okay, so we're not quite sure where C has landed yet. We're trying to prove that C lands on Z. So what we do know is that C is somewhere on this ray. Okay, ray means the extended segment. It's somewhere on ray YZ. Okay, it's somewhere on here for sure. Why is it somewhere on there? Okay, since both C prime and point Z are on the same side of XY, so now we've said they're on the same side as XY. So if it was here, C's over here somewhere. Okay, C's on this line somewhere. Okay, if it's this way, it's here. So once I've moved this over, okay, I know it's on the same side of XY. Okay, I know it's over here on the same side as Z. And I know it's on that ray because the angle is set. Okay, because it has the same angle as Y. They told us angle B and angle Y are the same. So I know once I set this down, this angle's the same, so C is going to be on the same line as Z. Okay, so now you've gotten, okay, you've told your reader, okay, move the segment over, okay, with a translation that will take it over there. If C is on the wrong side, okay, so if when you translated, or sorry, if when you transformed rigid motion brought AB to XY and C is on the wrong side, flip it over. Okay, so flip this angle over. So we know now that we've got XY set and we know angle B and angle Y are the same. So we know C is somewhere along this ray. So since, whoops, that should not say S. So since C prime and point Z, so since C prime and point Z are the same length or distance, okay, the same distance along the same angle, okay, are the same distance along the same angle from point Y. Okay, so they're the same distance. Okay, right? Why are they the same distance? Because these two segments are congruent. So they're the same distance from point Y, because B and Y are on the same spot. So they're the same distance away. They have to be in the same place. Okay, so first you said move the segment so that AB is on XY. If C is on the wrong side, bring it over. I know these angles are congruent, so C has to be somewhere along this ray. How do I know C lands on Z? Because C is the same distance from Y, because it's B, as Z. So C is the same distance away as Z is. So they have to land in the same spot. So first you got XY matched up, you flipped it over, and then you proved why C is on the same spot. So now we know, okay, so therefore, since I figured out that I can move A to X, okay, and B to Y, so now I've proven, okay, that A and B coincide. So A prime coincides with X, B prime coincides with Y, and C prime coincides with Z. That means zigzag or figure ABC is congruent to figure X, Y, Z. So your first move, move it over. Second move was to flip it if needed, because it could have been this picture. So flip it over, make sure it's on the correct side. Okay, so if it wasn't on the correct side to start with, make sure it is. Okay, so you can flip it over. Oh, I guess I moved the wrong one. Okay, so you can flip it over if you need to. Sorry, I moved the wrong one. Okay, so if it's on the wrong side, flip it over. If it's not, then you don't. Okay, but when you're doing the proof, you say, if necessary, flip it over. Okay, and then how do we know C landed exactly on Z? Because it's on the same side of XY, on the same angle, because these two angles are the same, and it's the same distance away. Okay, so what you're going to do is now you're going to take a look in your book, and you've got some statements here on a different set of zigzags. So you've got 5 statements. You want to put them in order. So which one did you do first? Which one do you do second? Which one do you do third? To prove that this one is congruent to this one. Okay, so use your time here to get these in the correct order. So pause the video and then come back. Okay, so if you remember, the first thing we did was said, all right, I know a set of segments is congruent, so I know that makes a rigid transformation, so I'm gonna do that, okay? So look for somewhere where they start talking about either QR congruent to XY or RS to YZ. So hopefully you found segments QR and XY are congruent. Okay, so QR and XY are the same length. So they're congruent. Therefore, there's a rigid motion that moves this one onto this one. So do that. Okay, so apply that rigid motion. Okay, then next thing. So after we've applied the rigid motion, so now we know QR is on top of XY. What we don't know is if it's actually this picture, okay? So then if necessary, we'll reflect it. If not, then we don't have to, okay? But we put it in there. If necessary, flip it over. Okay, reflect the image to be sure that they're on the same side. So let's make sure S is on the same side as Z. Then, once S is on the same side, then S has to be somewhere along YZ because angle Y and angle R are congruent. Okay, so they're on the same angle. Then S and Z are the same distance away along that angle. So S has to land on Z. Therefore, figure QRS is congruent to XYZ. Okay, then we're going to do another zigzag. So just talking about some things that we know and kind of doing a proof in a little bit of a different way. So when we're taking, so this is just a bunch of segments with different angles, okay? So taking turns with your partner, state steps of a proof that you would do to move this ABCD onto this one, okay? So how would you do it? So what do you know and why, and what would you do? So first things first is you're trying to get a congruent segment, an equal length segment onto another one, okay? So for instance, I know that AB and EF are the same length, okay? Because they're congruent. So I see this on here, okay? So what does it mean when they're congruent? Okay, what's the big deal? Is then I know that there's a rigid motion that will take AB over to EF because that's what congruent means. Okay, so then if I apply that, so that's going to move AB to EF. So therefore I can apply that, okay, and I can move that one over. Okay, so now you've proven that AB is on EF. Okay, so then what else can you do? Okay, so now you've proven that AB is on EF. So what else do you know? Okay, so what you'd want to do is make sure, so now if you've rotated this over here, then you'd want to say, remember, if necessary, reflect ABCD to be sure that C is on this, or C prime, because now we've reflected it, that C prime is on the same side of EF as G is. And maybe that's not necessary, maybe it is. Okay, but you put it in there. If it's necessary, do it. Okay, then I know, okay, and what else do you know? So then you know C will land on G because C and G are the same distance from F on the same angle, okay? And how do you know that? Okay, because now when you put this over here, B is on F and angle B and F are equal. Or congruent. Okay, so now you made sure C was on the same side. Now you know C is going to land on G because angle F and angle B are the same. Okay, then how do you know that D is going to land on H? Then I know D will land on H because D and H are the same distance from G, since angle G and angle C, okay, are equal or are congruent. Okay, the same distance from G on the same angle. Okay, since you know angle C and angle G are congruent. So rigid motion, move AB to EF, and then how does that ensure the rest of it? Well, make sure you flip it over so G's on the same side, if necessary. Then C lands on G because F and B are the same angle, and G and C are the same length away from that angle. So now you've proven E and F are in the same spot, or sorry, that A and E, B and F, C and G are set. So now how do you know D lands on H? Well, D lands on H because they're the same distance or the same length, okay? They're the same length away from G because C is on top of G. So D is the same distance from G as H is. So therefore, ABCD is congruent to EFGH. Okay, so get this written on your reference chart. And then remember, as you're working on your practice problems, there is a lesson summary to look through that has kind of a repeat of all of those directions. Okay, and you would just kind of continue following that along as you're trying to do zigzags.